The water from air revolution. How a new technology could change the future of water forever. What if one day, turning on the tap no longer guaranteed water? In 2026, that question no longer feels exaggerated. Around the world, climate change, prolonged droughts, groundwater depletion, and aging infrastructure are pushing water from something ordinary into something uncertain. For billions of people, safe, drinking water is still not something they can rely on every day. And when water disappears, everything starts to break. You cannot drink, you cannot cook, you cannot wash your hands. Hospitals struggle, schools lose basic sanitation, farms collapse under dry soil, food prices rise, communities are forced to move, and in some regions, tension over water becomes a real security issue. So water scarcity is not just about thirst. It is about health, education, food, dignity, stability, and peace. For decades, humanity's answer to water shortages has been massive infrastructure, build bigger dams, expand pipelines, construct larger treatment plants. And to be fair, those systems have done incredible things. They helped build modern civilization, but they also come with limits. They are expensive. They take years to build. They are difficult to maintain. They are vulnerable to disasters, conflict, and political failure. And most of all, they often do not reach the places that need them most, especially remote villages, dry regions, or communities living far from centralized networks. That is why a different idea is beginning to attract serious attention: atmospheric water generation, or AWG. In simple terms, it means pulling water directly from the air. At first, that sounds almost impossible. But the air around us is not empty. It carries moisture in the form of water vapor. You see it when a cold glass forms droplets on the outside. You see it when windows fog up in the morning. That water was always there. It was just invisible. AWG technology is built on a simple but powerful idea. If water exists in the air, why not collect it and turn it into clean drinking water? There are a few ways to do it. One method cools the air until water condenses. Another uses advanced materials that absorb moisture from the atmosphere and then release it when heated, often using solar energy. And this is where things get especially interesting. Recent advances are pushing AWG beyond humid cities and into far drier environments. Some systems are now designed to work using sunlight alone. Even in desert-like regions where water scarcity is most severe, that means the future of water may not depend only on rivers, reservoirs, or underground wells. It may depend on the sky above you. Of course, this is not magic. AWG does not create water out of nothing. It harvests what is already present in the atmosphere, and its performance still depends on conditions like temperature, humidity, materials, energy efficiency, and system design. In some places, it works better than others. In some regions, it is still too expensive for large-scale use. But even with those limits, the significance of this technology is enormous. Why? Because AWG represents a shift from centralized water systems to decentralized water independence. For most of modern history, water has been something delivered from somewhere else: a river far away, a dam built upstream, a pipeline stretching across miles of land, a government system keeping everything connected. But AWG suggests another possibility. What if homes, schools, clinics, villages, and disaster shelters could generate part of their own water on site? That changes the conversation completely. It is similar to what happened in energy. For years, electricity came mainly from giant power plants. Then solar panels and batteries began moving, energy generation closer to the user. Water may be entering the same transformation, from giant infrastructure to distributed resilience, from dependence to partial self-sufficiency, from waiting for supply to creating supply where people actually live. Think about disaster zones. An earthquake hits, pipelines break, roads are blocked, water trucks cannot reach the area fast enough. Now imagine a school gym being used as an emergency shelter, with solar-powered AWG units providing at least a basic supply of drinking water, not enough to solve everything overnight, but enough to protect lives during the most critical hours and days. That is not a luxury. That is survival. Now think about remote dry communities. In many places, collecting water still consumes enormous amounts of time and energy. Families may travel long distances just to secure enough for the day. When that burden is reduced, the impact goes far beyond hydration. Children may spend more time in school. Women may carry less physical burden, Clinics may maintain better hygiene. Communities may gain time, safety, and dignity. Water is never just water. It shapes daily life in ways most people in developed cities rarely have to think about. And there is an even larger implication. Water has always been linked to power. Control the river, and you control the farms downstream. Control the reservoir, and you control survival. Control the pipes, and you control the city. That is why water scarcity can become political so quickly, sometimes even violent. But technologies like AWG could reduce some of that pressure by giving communities another option, not total independence, not a perfect replacement for existing systems, but a new layer of resilience. And sometimes one additional option is enough to prevent crisis from turning into conflict. In that sense, technology may not just provide water, it may help prevent future water wars before they begin. Still, it is important to stay grounded. AWG is promising, but it is not a miracle machine. The systems can still be expensive. Filters need replacement. Maintenance matters. Water quality must be monitored carefully. And in extremely dry conditions, efficiency can still be a challenge. So no, this is not a silver bullet, but it may become something just as important. A practical, scalable tool that complements traditional water systems, and in some places transforms them. Now imagine the future. A family home with a compact water harvesting unit, sitting beside solar batteries. A rural school with rooftop panels, producing both electricity and drinking water. A remote health clinic no longer completely dependent on deliveries. A village where air becomes a backup reservoir when the ground runs dry. That idea would have sounded absurd not long ago. Today, it sounds increasingly realistic. The phrase harvesting water from thin air once felt poetic. Now it is becoming engineering. And maybe that is the deeper story here. This is not just about a device. It is about rethinking what infrastructure means. For generations, people believed security came only from bigger systems, bigger networks, bigger control. But the future may belong partly to something smaller, smarter, and more local. A world where resilience is built not only through central power, but through distributed access. In 2026, the water crisis is still very real. Millions still face uncertainty. Entire regions remain vulnerable. But for the first time, we can clearly see a different path emerging. A future where people do not only transport water, they generate it. A future where the atmosphere itself becomes part of the water system. And maybe one day, history will say that humanity did not begin solving water scarcity when it found a new river, built a larger dam, or drilled a deeper well. Maybe it began when we looked up into the air and realized that one of the world's oldest necessities had been floating above us the whole time.